Chapter 12 Atmospheric Hydrology, Section 12.2 Cloud Formation Processes. Clouds are simply condensed water droplets or deposited ice crystals that exist in mass somewhere above the Earth's surface, and we call these masses clouds. Clouds can develop in any type of air mass. All that is required is for saturation to occur. Several different atmospheric mechanisms can result in saturation, and saturation normally occurs when the temperature of an air mass is cooled either to its dew point or its frost point. One important process for cooling in our environment on the west coast of Canada is orographic uplift. So when air is forced to rise because of elevated land, it cools at the dry adiabatic lapse rate until it reaches saturation. So the dry adiabatic lapse rate is 10 degrees Celsius per 1,000 meters. And as I said, this is a common process for producing clouds and precipitation along the west coast of Canada. Another mechanism that can cool air is simple convectional lifting. So convectional lifting is associated with the surface heating of air at ground level. That air warms up quicker than the air surrounding it in its immediate environment. And that results in the air to become lighter than the surrounding air, and it rises just like a hot air balloon. As this air rises, it cools, first due to the dry adiabatic lapse rate of 10 degrees Celsius per 1,000 meters. And if it cools enough, it can reach saturation, or deposition can occur. So we can get the formation of water droplets or ice crystals. Air masses can also be lifted through convergence or frontal lifting. Where we have two air masses interacting, if we have a colder one and a warmer one, the warmer one is going to be lifted over the colder one. This lifting will cause the warmer air mass to cool, and if it cools enough, condensation can occur or deposition can occur, forming water droplets or ice crystals. Convergence or frontal lifting is a common mechanism associated with mid-latitude cyclones and their cold and warm fronts. And here we see frontal lifting occurring along a cold front. Usually the clouds that develop here are cumulus, cumulonimbus, and they occupy a narrow zone over the cold front. In frontal lifting, we get more stratus or nimbostratus type clouds. They occur over a much wider zone, and we have this warm air flowing over receding cool air, and clouds developing in the upper atmosphere. The final mechanism that can occur creating clouds is radiative cooling. So radiative cooling occurs when the sun no longer is supplying incoming shortwave radiation. Instead, the mass of air starts losing or starts cooling and losing long-wave radiation to the sky above. And if enough cooling occurs, clouds can form. When this occurs on the ground surface, we call it fog. So now let's look at two maps, one for July, one for January. And on these maps, we will display 14 years of data on global cloud coverage. From these images, we will see the effects of convection, frontal lifting, and orographic uplift in creating cloud cover over our planet. So here is the map for January. And in these red arrows, these are the locations where convection is going on. So thermal equator, extreme heating. It's also the meeting of the northeast and southeast trade winds, so there is a bit of convergence here. But the cloud cover that exists here, these are thunderstorms developing from daily heating. So convective storms that form on a daily basis. In July, the areas where these storms form move slightly closer towards the North Pole, but in similar locations. Now, India is a little bit tricky. I've got an arrow there. You know, it's a combination of convective storms and orographic uplift. Here are areas where frontal lifting is taking place. So the meeting of cold polar air and warm subtropical air, we're getting the formation of mid-latitude cyclones, cold fronts, warm fronts, and this is producing cloud cover. So in the North Pacific Basin, just outside or to the west of British Columbia, to the east of eastern Canada, a huge area of cloud cover that's being caused by mid-latitude cyclones. In January, if you've ever been to Great Britain, it's always socked in with mid-latitude cyclones and clouds being created from warm and cold fronts. And down in the southern hemisphere, there's a band of mid-latitude cyclones forming continuously just at the edge of Antarctica. Here are the locations of frontal lifting for July. So they move closer towards the North Pole, so more into Alaska. Notice that Quebec and the Maritimes, a lot of cloud cover there is mid-latitude cyclones around Iceland and in the Pacific Ocean Basin. And then once again, a strip along the edge of Antarctica. So now let's see if we can identify some areas where orographic uplift is occurring. The west coast of British Columbia, Washington State, Oregon, we can see precipitation there. Much of that is being generated from mid-latitude cyclones and the air masses associated with those mid-latitude cyclones being elevated orographically as they hit the mountain ranges in that area. You can see Scandinavia. There's elevation there, land elevation that is enhancing the precipitation orographically, and then I've got Japan located. In the southern hemisphere, we can see a band of greater cloud cover along the Andes Mountains in South America. So that's our January map. For our July map, once again, you know, the Alaska, BC coast, Scandinavia, Japan, and then the Andes Mountains. These are all areas where orographic uplift is enhancing the development of clouds.